Okay, page 5 and 6 of non-right triangle. We're going to do the sign rule. Show how this fact from our investigation leads to the sign rule. Well, remember that from the investigation we learned that the area of a triangle is equal to 1/2 times uh, the length of two of the sides times the sine of the included angle between those two sides. And actually, like any pair of sides with an included angle works. So if you know all the sides and you know all the included angles, you could write the area equation in three different forms like that. Once you set them all equal to each other, because they're referring to the area of the same triangle, you can divide each one of these by A, B, and C. A times B times C. Multiply all of them, or divide all of them by A, B, C. And then we can cancel out these variables from between the top and the bottom. For example, you have two B's, you have two C's. You have two C's, and you have two A's. You have one A, one B, one A, one B. So you're left with A on the bottom here, B on the bottom here, and C on the bottom here, which, oh, and then also you can get rid of all these halves, right? Because the halves are all in every single one. You can multiply each one by 2. So what you're left with is the sign rule, because the sign rule is sine of capital A over small a equals the capital of uh, big B over small b and the sine of big C over small c. Okay? So that is the sign rule that we just derived. The sign rule, I should have said can be used when you know blank angles and blank sides. Um, so if you know two angles and one side, or if you know one side and, oops, I'm sorry, two sides and one angle. Two sides and one angle. But it has to be a specific angle. It has to be a non-included angle. Okay, let's start our problems, and let's make sure our calculator is in degree mode. Yes, it is. Okay, number one, find the value of x. So we need to know that side, and we are going to use the law of sines. So let's say that this is angle A and this is small a. This is angle B and this is small b. Okay. Remember the same letter is always across from the same letter. Okay, so let's say the sine of capital A over small a is equal to the sine of capital B over small b. So let's do the substitutions here. Small b is 23. Sine of capital B is sine of 37. Sine of big A is sine of 48. And A is just x. Okay? So now you can see that all you need to do is use the calculator, find sine of 37, sine of 48, and then do a little bit of algebra, and you have the answer. So sine of 48 is, okay, 0.743. And sine of 37 is 0.602. We should use at least 3 significant figures, okay? So now you just need to do a little bit of algebra to find that. There's a couple ways you could do this. You could cross multiply if you like to cross multiply. Otherwise, you could just invert both sides. Instead of having 0.743 over x, you could have x over 0.743. And then the other one, instead of having 0.602 over 23, you could invert it. You could put 23 on top and 0.602 on the bottom. Okay? And then you just multiply both sides by 0.743 and you have a value for x. Okay, now we're going to do this one. Let's say that this is A and this is small a, and this is big B and this is small b. Now we're going to substitute into the same formula here. We'll have sine of 51 divided by A is equal to the sine of 80 divided by 4.8 kilometers. And so now we would just use the calculator to find sine of 51 and sine of 80, and then we would solve for A, and then we would have the answer. Okay, just do algebra just like last time. What is the ambiguous case which occurs when finding an angle using the sine rule? Do you remember how when we used the law of cosines, sometimes you ended up with a quadratic, and the unknown could be one of two different values, and both of them might be valid? So the same thing happens here, except with the theta or the angle. When you have sine, remember how more than one angle can give the same sign? So like if your unknown that you're looking for is the angle, then you might end up with a case where, okay, you know that the sine of the angle is something, a certain number, but there are two possible angles which can give that number. So that is why this is the ambiguous case, because if the unknown is the angle, sometimes the angle can be two different values. Okay? All right. Triangle ABC has angle 40, 8 centimeters, and C, 11 centimeters. Find the two possible measures of angle C. Okay, so here they're giving us an example where there are two possibilities. So first we're going to say this is angle B, which is 40 degrees. Side B is 8 centimeters. Side C is 11 centimeters. Side C could be this side or this side. It could be either one. We'll just put it here. Find the two possible measures of angle C. So let's say that's angle C. Okay. So we're going to write out the law of sines, which is the sine of A over small a is equal to the sine of B over small b. And in this case, we have B and C, so I'm just going to change the A's to C's. Okay? And then we're just going to substitute. So sine of C is going to remain sine of C because we don't know sine of C. Small c is going to become 11 because we do know that. Sine of B is going to become sine of 40. And small b is going to become 8. Okay, so now we just need to solve for sine of C. So the sine of C is equal to the sine of 40, which we can just solve here on a calculator. Sine 40, make sure you're in degrees, 0.643. So we're going to end up with 0.643 divided by 8 multiplied times 11. Okay? So the sine, or the angle C is going to be the sine. Let's see if we can find the sine of that. So that'll be 11 times 0.643. I can just do second answer. 7.07. I'm going to divide that by 8. So it's 0.884. Okay? So what angles have a sine of 0.884? And the calculator is going to give us at least one answer. And it'll give us, second sine inverse of 0.883, 62 degrees. Okay, so one of the answers is 62 degrees, and that's the one the calculator gives us. How do you find the other one? Well, the calculator is not going to give you the other one. You have to use what you know about the unit circle to say what angle that's going to be. So like, for example, 62 degrees, I drew it right here. Okay, that's on the unit circle. The brown triangle is the mirror reflection of that triangle, which also has the same sign. So if this sine is 0.884, this sine is also 0.884. Well, how do we find the angle of this triangle, which actually starts here and goes all the way to there? Well, actually, we can take this theta and we can find this new theta by saying pi minus theta or 180 degrees minus theta. That is the reflection about the vertical axis. So, in addition to 62 degrees, it's 180 minus 62 degrees, which is 118 degrees. Okay? So those are the two possible measures of angle C. So that is what's known as an ambiguous case. Is it possible to have a triangle with the measurements shown? Explain your answer. Okay, so we have 68 degrees here, 85 degrees here, 11.4 here, 9.8 here. Let's see. Can we use the law of sines to see if we can get, let's see, a valid angle for here? Actually, we do know the angle for here, right? Because the sum of the three angles of a triangle add up to 180, right? So we could add up these two, and they add up to about 158 minus 5, 153. 153. And so we'll take 180, we'll subtract 153, and then we'll get this triangle here. So this angle here is 27, right? So this is 27 degrees, okay? Now we're going to check if these lengths actually work together. So we'll say, okay, the sine of 27 degrees divided by 9.8 should be equal to the sine of 85 degrees divided by 11.4. And so we'll see if that actually works. Let's see, sine of 27 degrees divided by 9.8 equals 0.0463. 0.0463. Now we'll do the sine of 85 degrees, divided by 11.4. And that gives us 0.0874. So those are not equal. So I would say, no, it's not possible to have a triangle with these measurements. Moving on to number 5, find an x and y in the given figure. X and y. Let's see, what do we know? This is similar to the investigation we did, right? We could just, except now we know log sines and log cosines, so we could use log sines and log cosines to figure out these numbers. So let's see, this triangle here is the one we know the most about. The other one, let's say it's the brown triangle. The brown triangle has basically just a bunch of unknowns. So let's work on the red triangle first and see if we can at least get this unknown side, let's say this purple side, so that we can find a side that will help us determine x and y in the other triangle. So first, let's try to figure out what the purple side is. I'm going to name the purple side A, and I'll name this angle capital A, and then I'll name this capital B, and I'll name this small b. So now we could just write this out as the sine rule. So the sine of 118 degrees divided by small a is equal to the sine of 30 degrees divided by 22. And to find the length of A, we can just invert both of these. Sine of 118 equals 22 over the sine of 30. Sine of 30, if you remember, is just 0.5, right? Sine of 118, not so easy. Sine of 118 is 0.883. So we have A over 0.883 is equal to 22 divided by 0.5. So we could take the 0.883 and we'll multiply it times both sides, and then we'll put it here, 0.883, and then we'll just erase it from here, okay? So we have A equals 22 times 0.883 divided by 0.5. Let's multiply that out. 0.883 times 22 divided by 0.5. That gives us 38.9. 38.9. Okay, so A is 38.9. And then now we do know one side of the brown triangle. We're almost in a position to use law of sines for the brown triangle. But we don't have very much information here, and this is kind of hard to see, especially since I drew all these colors on it. But do you see the symbol right there? It's a little square in the corner, which means right angle. So using the fact that that's a right angle, we can figure out the angle here of the brown triangle. So let's see, we can easily figure out the angle here for the red triangle. The way we do that is we take 180 and we subtract out the two angles that are shown, which are 30 and 118. 30 and 118 add up to 148. If I subtract that off of 180, then I'm going to get 32. So the angle here is 32 degrees. And of course the complementary angle, which is the angle which adds up to 90 degrees here, is going to be 58 degrees. So we just found that that angle there is 58 degrees. We know that that's 95 degrees, so now we can figure out the remaining angle. We could just take 180 minus 95, that gives us 85. 85 minus 58, that gives us 20. 5 plus 2, 27. So the remaining angle is 27 degrees here. So now we know all the angles, we just don't know two of the sides. And remember, we do know A is 38.9. So we just need to figure out the proportion, sine of 95 over 38.9. And then we'll be able to figure out that that's equal to the proportions sine of 27 over x, and it's also equal to sine of 58 over y. And you can see that this is just algebra here. We're going to use algebra to isolate x and y, and then we'll have numbers for all those. And you know, of course, all these signs can be performed on your calculator, and you turn those into numbers too. Okay, so it's just a bit of algebra there. Number 7, in triangle ABC with angle ABC equals 30 degrees, AC equals 9 and AB equals 7, find the area of the triangle. Okay, so it always helps to draw a picture here. And they're using the famous 30 degrees. And we know that it's ABC with B in the middle because the B is in the middle here. Okay, and so AC is 9, AB is 7, and we do not know BC, right? And they want us to find the area of the triangle. Now, if we had known this angle here, then we would be able to use the formula 1/2 AB sine C. But since we don't know that formula, maybe we'll be able to figure it out using the law of sines, especially since this chapter is about law of sines. So sine A over A is equal to sine B over B. Let's see if that helps us figure it out. So let's say that sine B is 30 degrees, right? Sine of 30 degrees. Let's see, I'm just going to write here, sine 30. Sine 30. And small b, we actually know it's 9. Okay? And small a, we actually don't know it. Now, we could figure out maybe angle C, because angle C is opposite from a side that we do know. So we have sine of C over 7. And so now you can see we can figure out C using this relationship here. Sine of 30 is 0.5, right? So we have 0.5 divided by 9 equals sine of C divided by 7. So we're going to multiply both sides by 7. So we'll have sine of C equals 7 times 0.5 divided by 9. And the answer is 0.3888, which was 0.389, okay? And what is the angle C that corresponds to that? So we'll look up here, we'll do an inverse sine on 0.389. So we'll do inverse sine, which is second sine, and then we'll put 0.389. And then we'll get 22.9 degrees, right? So angle C is 22.9 degrees. And then now we can figure out that angle A is 180 minus 30 minus 22.9. So that's, let's see, 180 minus 30 is 150. 150 minus 23 is 127. Okay? So now angle A we know is 127 degrees. So now we can substitute that back in here. Instead of sine A, we're going to put sine of 127 degrees. And now we can figure out, we can put here sine of 127, and let's just figure out what sine of 127 is here. 127. It's 0.799. So here we can put 0.799 divided by A equals that. And so now we can use this relationship here, and I'm just saying it to 0.8. It would make it easy to calculate, right? 0.8 over A is equal to 0.5 over 9. So I can just, cross multiply or invert these. I'm going to put A over 0.8 equals 9 over 0.5. I just inverted both sides. You can do that as long as one side is not 0. And then I'm going to multiply both sides by 0.8, and so I get 0.8 up here. Okay? And then I'm going to multiply that out. I'm going to have 9 times 0.8 divided by 0.5, and I get 14.4. So the length of A is going to be 14.4, and that's what we were looking at. Is that what we were looking at? Is that what we were trying to find? No, and okay, I think we found a lot more information than we needed to then. So A is actually, now we know, is 14.4. So now we can use the formula from before that we discovered during the investigation. We know that the area is equal to 1/2 AB sine C, right? So the C value, the angle C, in this case, actually I wouldn't be doing 1/2 AB sine C. I would be doing 1/2 AC sine B, but same thing, right? Sine of 30 is a half. So I'm going to have a half times a half times each of the sides. So I have one side is 14, one side is 14.4. And so the answer is 25.2. So the area is going to be 25.2 square whatevers. Okay? And I just invaded the space down here. Oh, look at that. There's a problem with the Brazilian flag. Okay, 9D. Using the sine and cosine rules. Rodrigo wishes to determine the height of a flagpole. He takes a sighting to the top of the flagpole from point P. He then moves further away from the flagpole by 20 meters to point Q and takes a second sighting. The information is shown in the diagram alongside. How high is this flagpole? Okay, so let's see. What do we know? We know this is 28 degrees. We know this is 20. Do we know any other angles? Doesn't look like it, but wait a second, look at that. They tell us that this angle is 53, so we do know this angle, right? Because that's a supplementary angle, or two angles that add up to 180 degrees. 180 minus 53 is 27, or 127, sorry. 180 minus 53 is 127. So angle here, I don't know what you call it, but I don't know if it's angle P, is 127 degrees. Okay, and now that we know this angle, we also know this angle, right? So this angle would be 180 minus 28 minus 127, and I can't do that one in my head. 180 minus 127 minus 28, 25 degrees up here. So the top angle is 25 degrees. So now we could definitely use the law of sines to figure out some of these other sides. So let's see. We're going to make a proportion, and we're going to say sine of 25 degrees, which is the top angle, divided by 20 meters is equal to sine of 28 degrees divided by, and then we'll search for the length of this hypotenuse here. So we'll say that, we'll call that like, we'll call this, I don't know, Z, okay? So we'll call that Z, and then we'll take sine of 25, and that's 0.423 divided by 20 is equal to the sine of 28, sine 28, and that's 0.469, which is, yeah, 0.469 divided by z. And then we'll solve for z. So z would be, we could flip this over, and we could say, oh, z over 0.469 is equal to 20 over 0.423. And so z is equal to 20 divided by 0.423 times 0.469. And that gives us 22.2. So z is equal to 22.2. Okay, and so this hypotenuse here is equal to 22.2. Now we can do a much simpler trigonometry problem, which is the hypotenuse is 22.2, the height we don't know, and this angle is 53 degrees. Now it's quite simple, right? Now actually we could just use, as Banana would say, SOHCAHTOA, and we would have sine of 53 degrees is equal to h over 22.2. So h is equal to 22.2 times the sine of 53. And the sine of 53 is equal to 0.799. And we can multiply 0.799 times 22.2 to get the answer. 17.7. So the height of the flagpole is 17.7. Okay? And that was the answer, 17.7 meters, right? Last problem, number 3. A golfer played his tee shot a distance of 220 meters to point A. He then played a 165-meter 6-iron to the green. If the distance from the tee to the green is 340 meters, determine the angle the golfer was offline with his tee shot. Okay, and if you're not, if you don't really understand golf, basically they just drew the whole triangle here for you, and they want to know the angle that the golfer was offline with his tee shot. The tee shot was the shot from here. So he wanted to shoot directly to the flag, but instead he shot a little bit to the left. What is that angle? Well, we know all 3 sides to this triangle. So I think this is definitely a candidate for law of cosines. Remember, law of cosines is c squared, and this is going to be on your formula sheet, so you don't need to memorize it or anything, but you've already probably done so many problems that you have memorized it. I mean, it's got a nice symmetry to it. If you notice the A, the B, okay, the C, there, it's got a symmetry to it. Okay. So now let's see. Let's label our points. We want to know angle C, so this is going to be our angle C. It's the only angle in the law of cosines formula, so that has to be C. If this is big C, this is little c. And then basically A and B would be these 2 things here, right? Okay, so we know everything except for angle C. So we'll just start plugging things in. C is 165 squared. A is 220 squared. B is 340 squared, minus, and it would be 2 times A times B, so it would be 220 times 340, 2AB, cosine of C, which would be, we don't know what C is yet, okay? And so now we're just going to multiply things out. 165 squared is 27225. 27225 equals 220 squared, 48400, plus 340 squared, 115600, and then minus, and 220 times 340 times 2, 220 times 340 times 2. I'm using this off-screen calculator because it's a lot easier to punch the numbers into it, although unfortunately it doesn't have sine and cosine, so, and we have cosine C here. Okay, now I'm going to combine these terms, and I'll do that off screen so that you don't have to watch me. Okay, so I just did all this algebra off screen, but basically I combined 48,400 and 115,600 into 164,000. Then I subtracted 164,000 from both sides. That gave me negative 136,775. On the right side, I still had negative 149, 600 cosine C. I made both of them positive by multiplying both sides by negative 1. And then I divided 136, 775 divided by 149, 600. It gave me 0.914. Then I used the calculator to find the inverse cosine of 0.914. It gave me a angle C of 24 degrees. Okay, so he was 24 degrees off to the left on his tee shot. All right, and that is the end of this